Let's take a little deeper dive in programming for eigenmatrix, the WARBL specific elevation, roll, and yaw degrees of freedom into your presets. This can be porting existing presets or creating ones of your own. You're going to want to follow the configuration guidelines that are loaded up when you load your Haken Audio WARBL configuration file. And so elevation is CC74, your Y programming in your preset that will be output on MPE channel 2. So Y is part of your MPE XYZ dataset. Y will be at 0 in your min elevation, whatever you customize that to in the configuration that we talked about last time. And when you raise it to your max elevation, Y will be output at 127. Roll is twisting on the horizontal axis. Roll is a little less accurate than elevation because you can predict exactly where 0 elevation is. When you hold your WARBL at min angle or less, you know it's going to be 0. But you're always going to impose a little bit of motion as you hold your WARBL in its horizontal playing position. Roll is centered in your configuration. So when you hold the WARBL straight with no roll, with no twisting applied, ideally the value that will come out and the value your preset has to expect and program is 64 when there's no horizontal roll. Roll to the right and you'll start imposing values from 64 up. Roll to the left and you'll start imposing values 64 down till you get to 0, and as you go up till you get to 127. But again, you can't be quite as accurate with roll as you can with elevation. And yaw, which is the least accurate of the degrees of freedom, is moving the WARBL left and right on its horizontal axis, not twisting it. Holding it straight, that should get you an expected centered value. Yaw is also centered of 64, and as you move horizontally to the left, yaw will decrease till it gets to 0, and as you move to the right, it will increase until it gets to 127. So this is really what makes WARBL programming. Almost everything else you do in your preset is exactly as you would do it in a normal preset. Let's go through a few WARBL cases of how elevation, roll, and yaw are programmed. If you go in your system library and type WBL as a search, it will try and find that string and give you a list of all the presets with that in it. Most of those are WARBL presets. We'll take a look at additive horn. That uses 6 macros. Ambiance macro 4 is used in a lot of WARBL presets, but this one doesn't even have a pedal on it, so that's just a standard macro. But roll is set to none and yaw is set to none. Remember, always set macro 5 and macro 6, even if you're not using them, because you don't want to confuse things and by mistake use macro 5 and macro 6, perhaps left over from a system preset that you are porting, and have them have an effect that you really don't want. So always use 5 and 6, 5 roll, 6 yaw, and if you're not actually programming them, just say none. That'll make you compatible with all the other WARBL presets. So elevation is the only thing that might be used in this preset. Let's take a look at the formulas. Yes, Y, CC74 elevation is used in 2 formulas. The first one in formula C. This we can see uses a combination of X, Y, and Z, and they're added together, and they all go in the negative direction. This is used on the spectral dilation of the additive bank, so this will affect the timbre of the sound. And as X increases, your spectral dilation is going to decrease. As you give more breath pressure, it will decrease. And as you apply elevation, it will further decrease. Going negative, if that's what's going to happen here, you can see on spectral dilation, it will compress the spectral content of the sound. Formula E also uses Y. This one uses a Y plus Z formula, but this will increase values. This is placed on the convolution index. Convolution in this case ranges from leather to LVDL gong snapshot, and if it goes past that, it will go into fiber. The formula itself starts with y at 0.25. So when y is at minimum elevation, it's going to start at 0.25 index through that convolution. Just because your elevation is at 0, it doesn't mean you're having a value of 0 being applied. You'll start at 0.25. If you then give max breath pressure, you go up to an additional 0.5, 0.75, and then if you apply your additional roll, you'll go up to a max of 1.5. So you're going to go from 0 to 1 through the first convolution, and you'll go halfway through into the next convolution. That's how elevation is used. No roll, no yaw. Another big one we already talked about in the last video, bird whistler, uses roll.pitch, so roll does have an effect. Yaw is set to none, so yaw is not programmed in. Ambiance is set on macro 4. This doesn't have a pedal to it, so this is just a standard macro. Macro 2 is noise via Z, and then there is a speed control on macro 1. So let's see how Y is used in this preset. In Formula A, Y is added to Z. So when elevation is 0 and Z has no pressure is 0, it's going to initialize to a value of 1 plus 4. So you'll start with this formula being 5. As you increase your breath pressure, it will increase, but as you increase elevation, it will decrease. So the combination of elevation and pressure is going to dynamically change this value. That's set as a sinusoid frequency in terms of the grain. Sine sprays often use shape generator control on the grain frequency to impose some kind of iterative effect, in this case, a fluttering like a bird whistle. Formula C is totally scaled by Y. Now, Formula C starts by imposing a negative constant, and that is scaled by Y. So as you bring up your elevation, you're going to go from 0 down to -2. But this is placed on the minus line because there just weren't enough lines there to add everything. So a -2 on the minus line is just going to add another positive offset to this sinusoid frequency. Formula B has Y control. Y in this case is added to X plus Z, scaled by whatever your macro 1 speed is applied to the frequency of my shape generator. So Y will have an effect on the speed of the bird whistling, of the fluctuation that this preset produces. The noise via Z macro, Formula K, is applied to the frequency of the sine spray. This wasn't actually in the original bird whistler that this is modified from. This puts the macro on the Z formula. So when noise via Z is 0, breath pressure will have no effect, adding noise into the frequency of the sine spray. But as you bring up macro 2, your breath pressure will increasingly add noise. We can see macro 4 just controls the recirculator mix. Recirculator in this preset is set to long reverb, one of the new reverbs, and finally, roll.pitch, macro 5, affects Formula H and Formula J. Formula H is applied as a scalar, as a multiplier, to the sinusoid frequency and to the harmonic truncation and frequency of the sine spray. So roll is going to have a major effect scaling all these parameters. Formula H uses X as a main frequency component set to the octave mode. Again, as in the last example, using the N auxiliary function to turn your octave back into kilohertz frequency. And an offset is added to this with Formula J, also using a blend on roll. So both Formula H uses a blend on roll. This goes from a value of 0 primary to 12. So the initial value of this will be 6 because we've centered our roll as normal. And J is set to -12 primary, secondary to 0. So J is going to start off with an initial value centered at -6. However, notice that there's blend scaling being used on both of these formulas. Let's take a quick look at what this is actually going to do. I brought up a little test program that will explain this a little better. I have a formula that I put a blend on, macro 5, to simulate a roll, and we set it midpoint centered to 64 as all the other roll macros do. I have the primary set to 0 and the secondary set to 1. So 64 midpoint should bring this to 0.5. I scale it by Z, so at max pressure, this should be 0.5. Let's see. There's 0.5 in the formula display. But now I'm going to rescale that or create an offset. I'll take the blend transfer function and move that up 1. You can see the starting point lowers from 0.5 to a lower value. Look what happens when I continually do that. It will decrease the starting value, create an offset to that, and rescale it so that it starts at a lower value until it gets to a point where it just starts at 0. So at this point, it'll start at 0 and it will increase as you expect. We'll take the macro and see what happens if I take that from 64 on up. There you can see it went from 0 to its max value. Now, since the formula has a min of 0 on it, if I try and take that macro down, it's not going to do anything. It's already at 0. So this is a way of rescaling a formula that uses a blend to start at a different midpoint the way we're doing things here. Now let's do the opposite. Here's another formula where I scale it differently. Here it's scaled primary 1 and secondary is scaled to 0. But now what I'm going to do is take the endpoint and bring that down. See what happens when I do that. The same thing in inverse now happens. It'll start decreasing the value because I inverted it and I'm bringing the scaling down from the other direction. The progression is kind of nonlinear, by the way. So it's not the most predictable thing. You just have to experiment if you're using this function. But now let's see what happens if I combine the two. I have a formula which does the same thing we did in our original, start at 0, go to 1, but I've set it so that it's at the point where its value is 0. And now I add to that formula D, and formula D is the opposite. It has primary of 1, secondary of 0, and it uses this inverse transfer function on the blend. Now, and as I raised the macro, it went from 0 to 1, the max value, as if that macro had started at 0, even though it is a centered value. So this is a way of taking a centered value that would normally start at some midpoint in your range and have it start at 0 and go to max. Now, what's the difference between using just formula A versus using the formula C plus D approach? Well, if I just take formula A and I bring my blend up and down, what happens to the value? The imposed roll, as you can see there, will make it go from 0 to max, but as I take the blend down past halfway, it stays at 0. But what happens to the formula that has both of those options added together? Take the blend up and down, and you'll see in this case, taking blend going mid to max goes from 0 to max. And as I go from blend mid down, I also go min to max. So this is a way of imposing a roll that will do the same thing, going roll left and roll right. A few more things to note here. You'll notice that when I did my rescaling, it actually went to 0 a little bit before the final setting we have here. So I went back to A. I'm set at 64. I'll impose the motion. There I'm set at 0. Let me go one more. Still set at 0. In fact, I'll be set at 0 all the way to the end here. But if I start not on the point where it gets to 0, but on the next one, I'll impose a little bit of hysteresis, a little bit of lag before my increase starts coming in. I'll increase the macro, and notice the formula, it won't rise immediately. It starts after a little bit of hysteresis. So if I had gone back and changed that to the first place where 0 was hit, now when I start moving, it should start immediately to increase. Let's add even a little more hysteresis there. We'll start here, and you'll see now it's going to take a lot longer for my increase to start kicking in. There, it doesn't kick in until almost 3/4 of the way through. So by manipulating this blend offset, you can impose some hysteresis, some lag, and that's going to be helpful because your roll might never exactly be on 0.5 or your midpoint value. Same thing with yaw. By putting a little hysteresis in there, you can move a little bit and you'll still be remaining on your 0 value, give you a little bit of leeway before your roll or yaw kicks in. And the last thing to note here, if we go back to our formula C, we set that up as before. Primary is 0, secondary is 1. I'll put in that blend offset to start at 0. Now I'll go to my formula D, the formula that's added to that. Formula D, the primary is not 1 going to 0, minus 1, and the secondary goes to 0. And I have that initial offset put in there, so I'll start at 0. Now what happens when I bring my formula through its full range of roll motion? We'll start back at 64. From midpoint to max, we went 0 to 1 with a little bit of initial hysteresis on the positive side. And from midpoint down to min, we went from 0 down to minus 1, again with a little bit of hysteresis because we set our offset to a point where 0 would have been the next grid. So we put a little hysteresis in there too. Now we can go back to Bird Whistler. This uses the roll.pitch. It also uses Y, as we talked about, as a control of the main frequency of the warbling that's going on here, the whistling that's going on here. Play a note and go up on Y. And roll will affect the overall pitch of the sign spray that's being played. So roll.pitch will roll up an octave and down an octave. And if I combine that with the Y motions, I can get that nice bird whistling kind of effect. So let's take a look at the roll formula, macro 5. Macro 5 is put on formula H and it's put on formula J. Formula H is frequency controlled by X using the octave mode, translated back with the NN octave to kilohertz function. Macro 5 uses a blend just like what we were looking at. Primary is 0 on formula H. Secondary is 12, but it uses this blend offset to start at 0, not at the halfway point between 0 and 12, which would normally be 6. However, formula H also adds formula J. Formula J does something similar to what we looked at. it has a primary of -12 and a secondary of 0, and that is offset with our beginning offset to make that 0 to start, and that will now go down from 0 to -12. So when I add them together, we get exactly what we just looked at, and you'll notice a little bit of hysteresis is applied here. So we'll go and trigger the roll, positive and negative, roll right and roll left. Notice there's a little bit of lag, a little bit of hysteresis after I start the roll. It doesn't start immediately, so if I'm not exactly centered, I won't be changing pitch when I don't want to. Exactly using the formulas and constructions that we just talked about. And formula H is placed on the sine spray frequency, which gives us that frequency shift we were looking at. It's also placed as a scalar on the harmonic truncation and the spectral dilation. So this will affect a kind of a timbre change as well as the frequency change. And that's pretty much bird whistler. Let's end by looking at flip tube WARBL. This is another port of a system preset flip tube. This one is a little more complicated. It's more an effect preset than a totally pitched preset. If we look at the construction, this excites a bit graph using ramped noise. That is then sent in to excite the big bank. That big bank in the original is sent just to the master section. In the WARBL version, it's sent into the TAN-H processor, and then that is sent into a sum delay that gets a feedback loop through a low-pass filter into taps and out. So this is a tapped feedback delay loop. One of the things about tapped delay loops is the delay time can affect the frequency of what's being output. Now we have roll.pitch, and roll.pitch is formula K, obviously on macro 5, and formula K controls the sum delay time. So as I change this, and it's set initially using a blend, and you'll notice the blend doesn't have to be linear. It can be any one of the transfer functions, including graphs that are used for X, Y, and Z now, and that has a primary of 1, a secondary of 0.5, so its initial value is going to be 0.75. So this doesn't need to be centered on 0 because the pitch component that this is controlling is not frequency based on X. It's just a generic pitch control. Let's go in, I'll play a note, and I'll change roll.pitch. You can hear roll.pitch does affect the overall frequency of that vibrating wind tube. I'm not trying to set it to an exact frequency. I don't really care about that. But in a lot of presets that use feedback delay loops, the sum delay time is used to tune the actual frequency of the preset. I'm not so much interested in roll in this one. I want to look at yaw. Yaw controls the feedback. If I look at formula O, that's on macro 6. Formula O is combined with formula F. Formula F is actually what's used to change the input into that sum delay from the delay loop that's going through this low-pass filter. That uses a P scalar on, by the way, a polyphony scalar. So the more voices you play, the more scaled back it's going to be to limit the input into the sum delay so that it doesn't oversaturate. Polyphony scalars can be useful that way. And formula F uses that ancillary of formula O, and formula O is what controls yaw. Yaw is set to a value of 1. So the initial value coming out of this, here I've placed it so we can see what its value is. So the centered value of O will start at 0.5 as we expect. And then as you bring yaw up to max, it will go from 0.5 to 1, bringing in full delay input. And as you bring it down to min, it'll go down to 0, cutting off your feedback loop. Let's play with that a bit. We can get rid of this formula O since that's not really in the original. I'll play and I'll change the feedback. There's its default setting, centered. It quickly goes to nothing and delay disappears. But if I set it to max, whoa, got to be careful. Setting a delay to its maximum amount can saturate on itself as the delay feeds back and feeds back and feeds back. So you have to be a little careful setting very long delays in the eigenmatrix. You can oversaturate the delay and create a massive explosion if you let it go on for too long. Fortunately, with the warbler, you just have to set back to min and you'll get rid of that delay. So there's just an example of how yaw might be used in a preset. Only a couple of the WARBL presets use it, but of course you're free to use yaw and roll and elevation however you like.